Hello class, we're going to go ahead and look at section 6.5 notes, which is analyzing graphs of polynomial functions. So we have an example at the top of our note sheet. The percent of United States population that was foreign-born since 1900 can be modeled by the following equation P of t, where t equals 0 in 1900. Notice that the graph is decreasing from t equals 5, okay, t equals 5 to t equals 75. So t equals 5 is right here. So from this point to t equals 75, this point here, my graph is decreasing. And then it begins to increase. Okay, the points t equals 5 and t equals 75 are what we call turning points in the graph. And so one thing I just want you to notice is that if it's a turning point, it also is, if you look at this one is the lowest point, okay, or a low point, and this one is a high point. Okay, so they're what we call max and mins. So turning points occur at max and mins because we change from, this is decreasing, changing to going increasing. Okay, so that's where turning points occur. So real zeros of a function, we've already talked about this, but this is the x value where a function crosses the x-axis. So if I have this function, my zeros are wherever it hits the x-axis. A relative maximum is a point where the graph changes from increasing to decreasing. No other points around it are higher. Okay, so essentially from increasing to decreasing, this is a relative maximum. Okay, a relative minimum is the point where the graph changes from decreasing to increasing. No other points around it are lower. So decreasing to increasing, that gives me a minimum. Okay. Like I've already pointed out, relative maximums and relative minimums are also called turning points because that's where you change the direction from increasing to decreasing or decreasing to increasing. So let's go ahead and look at an example. You're going to need your calculator today. I will put up a video, there's one posted, on how to do this using the TI Inspire. But we're going to go through how to do this on the 84 today. So one says, graph the polynomial function f of x by making a table of values, describe the end behavior, and determine the number of real zeros the graph contains. All right, well, we could, to figure out all of these, we could go ahead and plug in, each x value. So in this one, we plug in negative 2.5 into our equation. Okay, we could do this for each and every single one of them if we wanted to. And if you did, you would get that this is approximately 8.4. But that seems awfully tedious. So what you can do is you can use your graphing calculator. So we're going to go ahead and do this on a graphing calculator. So on here, what you're going to do is you're going to go ahead and go to the y equals. Okay, and we're going to type in the function that we have. We have x to the fourth plus x to the third minus 4x squared minus 4x. Okay, and that is my function. And then we're going to go ahead and let's just kind of get an idea of what it looks like. Okay, so we can hit graph. Okay, if your graph function, if your screen doesn't look quite like mine, one thing that I recommend is going to zoom. And then if you go to zoom, number 6 says standard. That's going to give you the standard window. And by standard window, what I mean is your x values go from negative 10 to 10, and your y's go from negative 10 to 10. And one hint I would give you is if I tell you to graph something, and I give you the coordinate plane on your notes or your homework, look at how big the window is I gave you there. Okay, would it fit under that negative 10 to 10, negative 10 to 10 value? Okay, well now I actually want to figure out all the values for my table on my note sheet. So here's a nice little thing that you can do. We can actually make a table in our calculator. Okay, so what we want to do is go to table set, which should be right above your window button. Okay, so we're going to go ahead and do that. So in order to get there, you go second, hit window, okay, which gives us the table set, And the table start, what this means is what number do we want to start with? Well, our first x value on our table is negative 2.5. Okay, and then the delta table, that just is saying what do we want to count up by? Well, this one, if you go from negative 2.5 to negative 2, we're going by 0.5. Okay, and so now my table is set up. Now, in order to actually get it to my table, it's right above graph. So I would go second graph to get to my table. And look, it gives us all of the values for our table that we need. So I'm just going to go ahead and copy them over. You can take a look at these, but I'm going to copy them over. But they're all listed here. If you see, it's negative 2.5, 8.4, negative 2, 0, negative 1, negative 1.3, negative 1, 0. And I can go ahead and just copy all of those over. Okay. We just need an approximate value. Negative 1. So I'm going to go ahead and plot these values. So I have negative 2.5, 8.4. So I know I'm going to be positive up here somewhere. Negative 2, 0, negative 1.5, negative 1.3, negative 1, 0, negative 0.5, and 0.9, 0, 0. So I'm going to stop saying these and just plot them. Okay, now that I have them, I can also look back at my screen to make sure I know what my picture should look like. So I mean, by my screen, I mean look at my calculator. And the way you would just look at what your calculator looks like, you go back to graph. Okay. And the nice thing is you'll be able to have yours handy. You can look at this at the same time as while you're doing your homework or your notes. So that's what it should look like. So it's starting up, coming down, going up. Got to go all the way down and then all the way up. Okay, so there is my polynomial graph. It says now it says describe the end behavior. Well, my end behavior is when I talk about as x goes to infinity, what happens to my f of x values, and as x goes to negative infinity, what happens to my f of x values. Okay. Well, as x goes to infinity, that's my. If I'm going to the right, what's happening to my y values? They're going straight up, so they're going to infinity. Now, as x goes to negative infinity, I'm looking to the left. What's happening to my y values? They're once again going up, so they're going to infinity. The next thing it says, determine the number of real zeros the graph contains. Well, I look here, and I see how many times it crosses the x-axis. 1, 2, 3, 4. There are 4 real zeros. And we can actually say which ones they are. It's when x is equal to negative 2, negative 1, 0, and 2. Those are when my real zeros occur. All right. Example 2 says sketch the graph of the function. F of x is equal to x to the third minus 5x squared plus 3x plus 2 on the coordinate plane provided. Then we want to determine the consecutive integer values of x between which each real zero of the function is located. Then estimate the x-coordinate at which the relative maximum and relative minimum occur. So you need to find the zeros, the max, and the mins. So once again, we're going to go back to using our calculator. And like I said, if you have an Inspire, I would highly recommend pausing this, going and doing the video for that first so that you can follow along on your calculator. So I'm going to go ahead and clear this out. And so I have x to the third minus 5x squared plus 3x plus 2. Okay, and I'm going to go ahead and graph it. Seeing, will this fit on here, my standard window? It does look like it will. Okay, so now on your sheet of paper, what I would like is for you to make up your own table. And one thing that's kind of nice is if you hit on these little buttons here, you can kind of see what is my lowest x value that I would need to kind of find. Well, let's go to, this is a negative 0.83 repeating, so let's do negative 1. okay? And then negative 0.5, 0, and then go all the way up, and we can see how high we need to go up on our table as well by kind of looking on here. If I move this over, what value is this? This is a little more than 4, so let's go 4.5. So on your note sheet, let's go ahead and make a table. Kind of a little crowded, so just write small. So we're going to go negative 1, negative 0.5, 0, 0.5, 1, 1.52, 2.5, 3, 3.5, 4, and lastly 4.5. So we're going to go ahead, we're going to get the table of values on our calculator, then we're going to graph everything. Okay, so once again, going back to our calculator. Going back to our calculator, we have to, in order to do this, we need to go to table set. Table set, remember, is above your window. So second, table set. We don't want to start at negative 2.5 this time. We want to start at negative 1. And we're still going by 0.5, so we're doing well there. And then I'm going to go ahead and go to the table, which is above graph. So second, table. And I would just want you to write down all these values from your calculator on your sheet. Okay, so go ahead and write them down. I'm going to do the same on my note sheet. Okay, so this gave me negative 7, negative 0.9, 2, 2.3, oops, sorry, that'd be around to 2.4, 1, negative 1.4, negative 4, negative 6.1, negative 7, negative 5.9, negative 2, 5.4. Okay, now I'm going to go ahead and graph those. So negative 1, 7 is going to be way up here somewhere. Negative 1/2, negative 0.9 will be down here. Oh, sorry. Is it supposed to be negative 7? Yes, sorry. It's supposed to be negative 1, negative 7 here. So we will actually have a point that is negative 1, negative 7 down here. Then, sorry, we're going to go negative 1/2, negative 0.9, 0, 2, 0.5, 2.4, 1, 1, 1.5, negative 1.4, 2, negative 4, 2.5, negative 6.1, 3, negative 7, 3.5, negative 5.9, 4, negative 2, and 4.5, 5.4. So that's going to be up here somewhere. Okay, so now I go ahead and graph this one. Checking, you once again check the image on your calculator, making sure that it's, you know, doing the same kind of shape. Okay, so there is my, there's a sketch of my polynomial. Now what we need to do is we need to find the zeros, okay? It says an estimate. So we could estimate my zeros are here, here, and here. So what you could do is you could say it's between negative 1 and 0. And then my next one is in between 1 and 2. And then my last one is in between 5 and 6. Okay. But you can also find these on our graphing calculator. The way you can find zeros is by going to, we're going to go back to our graph, so let's look at our graph. So we're going to find a zero. There's a ton of options under the menu of calc, which is above trace. So we're going to go second calc. Okay, second calc. And we want to find a zero. Do you see how number 2 is 0? So you go down to 0. Okay. And now it says left bound. So if I want to find this 0 right here, I need to be located to the left of that point. So anywhere down here would be left bound. So I'm going to move the little thing that's flashing to the left, and then I'm going to move it to the right. Enter, and then it says guess. You can try and move it closer, or you can just hit enter. And it actually tells me my 0 is negative 0.391. Okay, so that is my actual 0. Let's go ahead and find this last one because I'm not sure if my graph looks very accurate. So calc 0 again. Now left bound. So I'm saying I want to figure out this one right here. So to be left bound, I just need to be to the left of it. So I would hit enter. Now I need to be right bound. Enter. Guess. So this one says 4.164 is my 0. So my graph does not look very accurate. I made a mistake somewhere. So it really wouldn't be in between 5 and 6. It'd be in between 5 and 4. Or 4 and 5. And we could also specifically state what all my zeros are. And when I did this one, x was 4.164. I will leave it up to you to do this one. Try this one on your own. If you do it, you should get x is 1.227. Okay. Now the next thing I need to do is go ahead and look at my maximums. My maximums are my highest points on my graph. So here is my highest point. So we could estimate that one, and we could say, well, it's between, if it just wants an estimate, it's between 0 and 1. Okay, but here's the beauty. Once again, your calculator will help you find it. Okay, so let's go back to our calculator to see how that works. So if I want to find my maximum value, I'm going to go second, calc. Okay, I want to find my maximum, which is number 4. So I can either arrow down to number 4 or hit the number 4. Now it says the same, I did not hit the right thing. We want to find the maximum. So I need to be left bound. So once again, I need to be, if this is my max point, I need to be to the left of it. Then I need to be to the right of it. So I need to get that little flashing cursor to the left of it. So I would hit enter. Now I go to the right of it because it says right bound. And I would hit enter. And it tells me my maximum is 0.33333, so it means it's 0.3 repeating, which is the same as 1/3. Okay, so if I wanted to, I could actually say what my x max is. It is x is equal to 1/3, and they actually tell you what your y value is for it too. So if they wanted the ordered pair for this one, it says it's 1/3, and 2.481. Okay, so that would be my max point. Then I can also go ahead and find my minimum. My minimum is right here. So if I want to do that, I go back on my calculator.
We'd love to have you come and hang out with us and learn some cool things. Have an awesome day. Oh, by the way, we're in room 2411.
Okay, so if I want to find my maximum, sorry for the intercom, I would go once again, second, calc. Okay. And I would go to my maximum, or sorry, we're finding my minimum this time, so I go to minimum. And now if I'm trying to find this point, to the left of this point would be over on this side, and to the right would be over here. Okay, so I just need to be to the left. So I am to the left, so I'm going to hit enter. Go all the way to the right, and hit enter. Okay, and then I want to hit enter one more time. And so now it tells me, telling me my 0. It should be my maximum. Let me just double do that. So my minimum is number 3. To the left of that would be here. Now I go to the right again. And enter. All right, so my minimum. It says minimum. So if it said 0 by it, I accidentally hit the wrong button. So the minimum is 2.9 repeating -7, which is essentially when x is equal to 3. And if I asked for the actual ordered pair, it would be 3, and then they gave me -7, which is the point that was on our graph. Okay, I'm going to go ahead and stop the video here for and we'll pick up. So I want you to take a break, make sure you know how to use your calculator, and then I'm going to come back with the other problems, and I'm already going to have found the table of those values. So I would like for you to go in for number 3 and 4 to go ahead and already have found the values. For number 3, my recommendation for your table is if you look at the table that they gave us, we're going by 2's. So on our table, when we find our table of values, I'm actually just going to go ahead and go by 1's this time instead of 2's, or sorry, by 0.5. So I go 0, 1, 2, 3, and 4 and 5. So I want you to go ahead on your calculator, fill in that table for number 3. And then for number 4, okay, we'll go ahead and look at number 4 together. But I want you to get the table of values for number 3 on your own, and we'll pick that up in the next part of the video. Okay, so go ahead, do that, and then come back to Schoology and watch the second part of the video. All right, have fun doing that, and I'll see you in a little bit.